Welcome viewers. In this video we'll see the digital register. The type is bidirectional shift register. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic bidirectional shift register. We'll see what is meant by bidirectional shift register. If a binary number is shifted left by one position, then it is equivalent to multiplying the original number by 2. So while shifting left side by 1 bit, it is equivalent to multiplication by 2. Similarly, if a binary number is shifted right by one position, then it is equivalent to dividing the original number by 2. Right? So the left side means multiplied by 2, right side means divided by 2. So by using this bidirectional shift register, we can move the data either left side or right side. So that is equivalent to multiplication or division. So for that purpose, we are using this universal, using the bidirectional shift register. I will see the further details. Here, if you want to use the shift register to multiply or divide, then the binary number, given binary number, then we should be able to move the data either in left or right direction. In order to perform the multiplication or division, we need to move the data either in left side or right side. Such a register is called a bidirectional register. A 4-bit bidirectional register we will consider. We will consider the 4-bit bidirectional shift register. So there are two serial inputs, namely serial right shift data DR, serial left shift data DL, along with the mode selection M, along with the mode selection M. We will see the diagram. So we have DR, data right shift, DL, data left shift. In order to select this, we have mode control. Now we'll see the diagram, logic diagram. So this is the logic diagram of the universal is a bidirectional shift register. Bidirectional shift register. So there are 4 flip-flops available. Flip-flop 0, 1, 2, 3. There are 4 flip-flop available. This is the clock signal. Clock signal is given to all the flip-flop. Right. So here we used the D flip-flop. What is the nature of the D flip-flop? Why we are using the D flip-flop? The D flip-flop, we know that the input is D, the next present state is Qn, next state is Qn plus 1. Suppose the D is 0, whatever may be the present state, the same 0 will be available as the next state. If D is 1, whatever may be the present state, the same 1 will be available as the output. So whatever may be the present state, D will be reflected. The value of D will be reflected at the next state of the flip-flop. So that if we pass the data 0 to the input of the flip-flop, the same 0 available at the output. If we pass the data 1, the same data 1 is available at the output. So that we can easily shift the data from right side to left side or left side to right side, or we can pass serially, parallelly, all are possible, because what we are sending, the same thing available at the output. If you pass 1 at this D3, Q3 also 1. If D3 is 0, Q3 also 0. So there is no change. So that can be, so the property of the D flip-flop such that same, input and output same, so that we are using the D flip-flop for the register, digital register, for sending the data serially or parallelly, shifting right, left, everything, we are using D flip-flop. Right. Now we discuss about the D flip-flop. Now we'll see how to control the data left side or right side. See this. Here one control, mode control is available. Mode selection. And one more NOT gate is connected, so that M bar is available in this line. The first line we have mode signal M. Second line we have mode signal M bar. M0 means M bar will be 1. M1 means M bar will be 0. Right. Now we have the logic diagram is available here. Two AND gates and one OR gate. It is named as 1, 2, 3, 4, 5, 6, 7, 8. Right. Now we'll see what will happen. if it is right shift or left shift, right? So this the right shift data is entered at this point, DR input. The DL input is entered at this point to the AND gate 8. DR input is given to the AND gate 1, right? Now we'll see what will happen. If M equal to 1, if M equal to 1 means this line will be logically high. This time will be logically low, right? So in this line we are connected the 3, the AND gate 3, 5, 7, then 1. 1, 3, 5, 7 are connected, right? So 1, 3, 5, 7 will be activated. 2, 4, 6, 8 will be deactivated. See this, the left side data we cannot go for, this deactivated. 1 is activated, so the right side, shift left, shift right is possible. So the data is entered here. This is already high, so that is goes to the OR gate. OR gate nature is any one is high, it will be high. So the data will be passed to the first flip flop, right? So the M is high level, so the AND gate 1 is activated. The data what we need to shift right side is given to the AND gate 1. Based on the value, it is goes to OR gate, then OR gate value goes to D. Either 0 or 1, that will pass to D3. The same thing will be available at the output of flip flop Q3. This Q3 is given to the AND gate 3, right? This 3 also connected to high level, so this is activated. So that input is given to second flip flop. Then output of second flip flop is given to the fifth AND gate. So this is also already activated. 1, 3, 5, 7 is activated. From 5 it is given to the third flip flop, input of third flip flop. Output of third flip flop is given to the AND gate 7. From that it is given to fourth flip flop, right? So now the data is shifted right side. Data available here, that is passed to the first flip flop. Output of first flip flop is goes to AND gate 3, that is passed to second flip flop. Second flip flop output goes to AND gate 5, that is passed to third flip flop input. Third flip flop output is goes to AND gate 7, that is given to the fourth flip flop input. Then it is goes, just keep on going, right? So the data is shifted right side. Suppose if the M is 0, what happened? This line is deactivated, that is 1, 3, 5, 7 AND gates are deactivated. Here 0 means M bar will be 1. So this line will be now activated. What is that? The AND gate 2, 4, 6, 8 are activated now, even numbers 2, 4, 6, 8, right? So in the 8th gate we are giving the data which is want to shift left side. Now we given the data this side, now we are giving the data this side, left side. So the data is entered into the AND gate 8. From that it goes to OR gate, then data is given to the fourth flip flop. Now this, if we consider 1, 2, 3, 4, this is the fourth flip flop. The output of this fourth flip flop is given to sixth AND gate. So this is also already activated. From that it is given to third flip flop input. Output of third flip flop is given to AND gate 4. From that it is given to second flip flop input. Then output of second flip flop is given to the AND gate 2. From that it is given to first flip flop. Then this output again goes to the next step, right? So from this side the input is goes to AND gate 8, then flip flop 4. Output of flip flop goes to AND gate 6, then it goes to third flip flop. Output of third flip flop goes to AND gate 4. From that it goes to second flip flop. Output of second flip flop goes to AND gate 2. From that it goes to flip flop input of the first flip flop. Now the data is shifted left side, right? So based on the M value, either we can shift the data right side or left side. M is 0 means the data entered from this point and shifted right side. M is 0 means this line is activated, data is entered here and shifted left side, right? Now we'll see the description. Now we'll see the logic operation of this logical diagram. First case, when M equal to 1, we can perform shift right operation. That is, if m equal to 1, then the AND gates 1, 3, 5 and 7 are enabled, whereas the remaining AND gates 2, 4, 6, 8 and 8 are disabled. Right. The data is entered at DR is shifted to the right bit by bit from flip-flop 3 to flip-flop 0. That is, first flip-flop to fourth flip-flop on the application of clock pulse. Thus, with m equal to 1, will get the serial right shift operation. Similarly, if m equal to 0, what will happen? If m equal to 0, we can perform shift left operation. When the mode control m is connected to 0, then the AND gate 2, 4, 6 and 8 are enabled due to NOT gate is connected, and 1, 3, 5 and 7 are disabled. Now the data to be shifted left side DL is shifted bit by bit from F00 to F3. This is the fourth flip-flop to fourth flip-flop to first flip-flop on the application of clock pulse. Thus, with m equal to 0, we can get the serial right shift operation. So in this video, we discuss the shift register, universal shift register. We have that mode of, based on the mode control, we can shift bidirectional. We discuss the bidirectional shift register, shifting right side or left side, that is decided by the mode control. If mode m equal to 1, shift right operation, m equal to 0, shift left operation. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.